Okay, welcome back again to all the participants. We are going to start the second session, and that is a basic session on the coding for a data manufacturing. And that the session will be given by Dr. Sunil Kumar. I will give brief intro about him. Dr. Sunil Kumar is an associate professor at the Department of Mechanical Engineering, Slight Longowal, Punjab. He received BTech degree from REC Jalandhar, PhD from Slight Longowal, and ME from Thapar, Patiala. He has 17 years of teaching experience. His area of interest includes dynamic, kinematic, CAD, and robotics. He has guided more than 20 MTech theses and guiding 3 PhD students. He has published more than 35 papers in international journal and national journals for and conferences. Welcome, sir. So we'll start with the session.
Thank you, Anuj, for your nice introduction about me. Mm, all the participants, this is your last day in this short-term course on hybrid mode on recent trends in additive manufacturing in hybrid mode. Few participants are here, and many are on online. We're glad to see some of the participants physically present here. This reminds us old days when we used to have these short-term courses with full-fledged in-house systems. And I hope this will end and we will have more participants in our next coming short-term courses or other such events. So today my lecture is on introduction to G course for 3D printing. So my basic, as Anuj has said, my basic research area is CAD and robotics. So I have put some slides related to CAD. CAD, or you can say about the progress in design field, what from where we have started and where we are today, and then I will move to some basics about G codes for 3D printing. So this first slide here, it shows that from our handwriting, or we used to write something not more than we have 5,000 years ago. We have three languages which are in. You can say we have a proof for that. That is Tamil, Sanskrit, and Egyptian. Before that, we don't have any proof of any writing skills. But for a long time, we were dependent on the handwriting, and each area has developed their own writing depending upon their speaking capabilities and speaking languages. And first thing which we used to write the things without writing using our hand was typewriter. It was developed in 1867. And after the programming and the electronics was developed, boards were developed, computers were started. The text was typed in our you can say computers in some form, in dot forms or DOS modes in 1960. And then Microsoft Word was developed in 1975, which make it more convenient for students or for the peoples or interacted between machine and human beings. And more people were connected to computers. And then handwriting recognition, search on handwriting recognition was started. And nowadays we can write in our own language or in our handwriting, and that can be converted into standard formats of the text. And now we have very much higher level capability of voice recognition. You can speak something and it will straightforward write with almost 99.9% accuracy. So we have started from simple handwritten, and now we have reached where we can speak and that words will be typed automatically. Similarly, in case of designing, I think many of us might be knowing about this Leonardo da Vinci, who first gave us the designing, that how to first we have to design, then we have to manufacture. Previously, from the days of, you can say from the Stone Age, we were just we were just manufacturing the things by using our hands, and then by as the improvement in humankind was developed, we used tools. But design was first introduced by our Leonardo da Vinci, who gave us some very good sketches with some dimensions, and it took carry on for a long time, and then the engineering was started in early century of 80s. And then when engineering was introduced, 2D drawing was introduced in the form of your blueprints using your drafters and sheets. And then 2D drawing was introduced in the programming, where you didn't need any drafter or pen. Everything has been done by your mouse, using different icons or words in the software. Then 3D modeling was developed. Then now you have haptic aided designing, where you need not to even put some icons. You have to move some predefined entities, or you can move your wear some gloves and move. As you will move that gloves, the picture or the dimensions will automatically be calculated through the software, and that thing is being created. Nowadays we have 3D scanners, in which we put more than three cameras, mostly cameras or infrared devices, which take the which recognize the object from three different dimensions. And then by using your different transformation matrices, we create a object. So you need not to create by your own, or by using the icons. You can just wear some gloves or some instruments you can use, and you can make an object. Or you can just have three cameras. If you want to do re-engineering, you can take those pictures from the three cameras, from all the three dimensions, and you can create a model, 3D model. So this was the journey of designing. And then how we can say what is the future of your CAD. As we all know, from I think more than 30-40 years, we are studying about the CAD CAM. Then it has upgraded to CAD and CAE, that is computer aided engineering, which involved more things. If you have all studied about the MRP system, ERP system, SAP lab, that includes all the things. In CAD, we just have a portion that is of only design. In CAM, we have portion of manufacturing, computer aided manufacturing. Then if we involve MRP, then we mix both designing and manufacturing. That means we take data from the CAD, that is design, and that data is given a shape which is required by the manufacturing section, and that shape or that data is used for manufacturing to directly manufacture the object. So in engineering, other aspects also includes, like what will be the process to manufacture a thing, or what should be the production schedule, or inventory control. All the things are involved, that each and everything in an industry can be done using computer. And then we have computer aided industrial engineering. As you all know, we imply TQM, and other tools to improve our production, to reduce our errors, or to reduce our waste. So that thing is also being included using this CAID. And in future, we hope there will be a computer aided consumer design. Means consumer will provide us the information what he needs, or he or she needs, and that will be manufactured. And I think this is happening in higher end our vehicles, like Rolls-Royce. Why I am saying about this computer aided consumer design? Because it is the interaction between the softwares and the its user is very easy nowadays. I remember when I used to study in 1999, I have started using AutoCAD, and at that time there was no icon in the AutoCAD. Whatever we have to draw, we have to type whole line. For example, if I have to take the command of line, I have to type the command line line or use word L. But nowadays it's not like that. You have icons. You can just see and you can identify that this icon is for what and this icon is for what. So this is a lot of the difference. As we are progressing, the more interactive systems are coming. So these are some softwares which are used in all over world for designing purpose. But most of these softwares they cost us. If you are in industry, obviously industry has to buy, or if you are in institute, then institute have to buy it, or either student version or depending upon what type of version you want. But if independent person want to use this software, it costs high for them. But it's not like that that if you don't have those software you cannot do. There are many softwares free of cost available on the internet, almost similar. Obviously they are free, there will be some limitations, but to design something, to get some STL file for 3D printing, these softwares are very good. You can explore these softwares and you can make practice, or you can use this. This is why we are, I have said that consumer aided development will be there, or consumer aided system will be there, because consumers will be using such type of softwares directly. They don't need to study about the mechanical engineering or civil engineering. They will use directly these softwares and provide their design to the manufacturer to develop this can be in future, and especially when AI is there, it will definitely give more good shape and more good features to their or aesthetics to their products. So again, if I think today, if the students of 10th, many of them have started learning the programming softwares. If they want to develop their own software, so which softwares they have to use, or they are learning about this software. So in my view, if you are doing anything, you are in any branch, you are in any field, whether it is engineering or medical or any other field, my view is that if you are in studying something, or you are in higher studies, you should know these three languages, at least one of these language. I think previous lecture was from Professor Harpreet. He also said that although their main major work is in material characterization, but he, I think once or twice have said that his students are working on simulation softwares, right? Sometimes they used to program their own program, and they edit or they attach it with these MATLAB or Python or C++. So they cannot do until they know this. So for higher, I think one should know at least one of this software. Then as this short-term course is related to additive manufacturing, so there are many softwares available for 3D printing that you can design different models, and then you can create STL file and import it to your 3D printer. Right, these are many softwares. Of these software, I have taken some material from Ultimaker, Quora, Simplify 3D, and LV for my presentations, and even from Silice 3R. So these softwares you can use. It will be definitely, there will be a little bit difficulty if you are new to the this designing field. or developing modeling. But if you know any software like AutoCAD or SolidWorks or CATIA, I think if you will go through these software, there is different look, but almost similar things are there. So you can create the things in these software if you don't have specific softwares. In India, most of the companies, if we talk of industry, mostly the people, especially in this north part, most of the industry are using SolidWorks for modeling and to create their program for conventional machines, simple like lathe or milling machines, or for even 3D printing. Most of them are using SolidWorks. So if someone is looking for placement, or you want that your students should be placed in white collar job in mechanical engineering, then my suggestion is they should know about the SolidWorks if they want to work in India. And if someone wants to work in America, they can go for ProE, or nowadays known as Wildfire. And in Europe, mostly CATIA is used. So if someone want to have white collar job in India, then SolidWorks software should be known to him. So now I am coming to my basic lecture about G code. Most of you, if you are from mechanical engineering background, I think G codes you might be familiar with. Mostly CNC machines, whether it is a milling machine or any machine, they use G codes. When we say G codes, it doesn't mean that all the codes are starting from the G, word G. So what is the role of G code in 3D printing? Let me discuss this first. Till now, whatever you have heard about type of 3D printers, and I think all of them has said somewhere where about STL file, .stl file. That .stl file is created in some modeling software that is imported to the your 3D printer, and 3D printing starts printing. Any type of 3D printing, whatever you have heard till now, most of them uses .stl file. Now, when you put that STL file in the 3D printer, and the printer starts the printing, something happens between that. And what happens? Some commands are given to the extruder where it has to move or what it has to do. So if we have a 3D object, it is divided into slices. I think you might have heard about that. So, because it works in a layering system. So it is okay. We know that layering system, it will work, 3D printing will work in slices. But how that is created inside the software, that is done with the help of G code. These G codes are similar to the G codes, most are similar to the G codes which are used in CNC machines. There are little bit difference, little bit added codes, G codes, which are used specifically for 3D printing. So when STL file is called in the printer, a program is generated. You can say G code program is generated, and that program is in, I think, more than 1,000 lines, or even more than 1 lakh, depending upon the structure you are being printing. There will be number of codes, and that all codes will be in the form of G codes. So what numbers or what codes or what alphanumerical values will be there, we will little bit discuss about that today. So G code, we can say it is a text script which is generated by the software when we put STL file to our printer. So there is a software in the printer which creates slices and creates G code from the STL file we have imported from the modeling software. So that codes when generated, as in CNC, if you have ever worked on the CNC or seen in CNC working, whenever the command is going, whatever the line is highlighted, that command is activated at that time. So what happens? One line goes to the buffer memory, and from buffer memory it goes to the command or goes to the you can say your equipment, to which equipment or which part has to do what, where the signal has to go, whether it has to move the slider, whether it has to rotate the motor, or whether coolant has to be on, coolant has to be off, or door has to shut down. Generally this happens in your CNC machine. So each steps sequence wise goes to the part where it is required to go. Similarly in 3D printing, these codes are generated and each line is then fed to our extruder or the different parts of our 3D printing which produce some motion. So 3D model, as I said, slides are used to have your printing. Now, in conventional lathe machine or turning machine, we have some parameters, as we are most of our academician and we know the parameters. In lathe machine, mainly we used to control what? We used to control mainly three things: is speed, feed, and depth of cut. And as we control this, the final product gives us the shape accordingly. If we want very high surface finish, then we have to increase our speed. So for different materials, we have different combinations. Again, it will also depend upon the tool. So in welding, if we say there are again some parameters which are to be controlled, that is speed, then your current, voltage, accordingly, what you are welding, what is your electrode. So these are the parameters. Similarly, in 3D printers, you have again some parameters which are to be controlled. Right? These are layer height, speed, infill pattern, and many other such type of characteristics or parameters which are to be controlled. So these are done with the help of your programming. We give some feed, and researchers are working on this. That it's not that our feed is continuously same for one particular product we are making. It can vary. What will happen if variation is less or variation is more? Do we require variation or not? In some cases we require, in some cases we don't require. So this is also part of your research. Now these 3D codes mostly today, as we know where we are, softwares themselves generate these G codes, right? But we should know what is inside those codes. So simple G codes actually vary from machine to machine, use of machine to machine. Some are common codes we will discuss, but not all the codes like threading code in milling machine cannot be used in 3D printing, right? These are simple to read, very easy language to understand, but again, it's not that if it is simple and we can generate our own codes, because it will make the difficult for the user end. So you have to provide whole manual. Mostly like I think you might have heard about some codes like G00, G01. These are standard codes, and all of the manufacturers of CNC machines or 3D printing machines, they use these codes for that particular task, for travel task only. It's not that some machine is using G00 for rapid travel and some other machine is using G100 for rapid travel. So there are some standards codes. We should follow that, and we should not generate our own codes. It will make difficult for the users. So how this G codes are created in the 3D printing system? Each our STL file or 3D model is divided into the slices depending upon the height, whatever we are giving input to our system. According to that height, each layer is cut, and then directions, or you can say coordinates are measured, and then we connect those coordinates with the help of our G codes. Right? If you have a circular arc somewhere, then we have to use circular code for that. If we have linear straight line, then we will use some linear. If somewhere some material is missing, then you have to use some other code, right? So again, some addition is there in this. You have in generally in conventional machines. Again, I am taking example of lathe. There is a tool which cuts, right? It doesn't give some material, but in case of this, some material comes out from the extruder. So its rate is also very important, right? So there is feed F word is used generally in CNC machines, but here we have again we have more parameters like E, which also has to control the rate of rate of material which is flowing through that extruder. So there are simple words which we use to create the coding. How to read G code? So G code is if once you understand the meaning of the words, which word is used for what, it will be very simple to understand the whole program, right? Generally, when we use word G, it stands for geometric commands. That means some geometric function is going on, some moving will be there in the form of linear or circular motion. And there are other codes which are non-geometric codes like M codes. For example, in machines, in CNC machines, M codes are used for coolant on, coolant off, program start, program end, and lot more codes are there. Similarly, here we have codes like to increase the temperature of extruder, to increase the temperature of your bed, to maintain the temperature of bed, to maintain the temperature of extruder, or to give the coolant if required in some cases. So there are a lot of M codes. Along with M codes, there are other codes also like E code and F code, S code, and other codes which we will discuss. So generally, this line as it is showing, this type of lines are shown in the program. So we have this type of lines. So if you just see this line, we have some alphabets and we have some numerical values. So if I want to read this line, what is what? So first one, there will be some numerical value. In case of CNC machines, if you know, we use N word and then we write your line number. Here we don't use N word, we straightforward write our number. So when first number in this 3D printing G code will be a number which have role to identify the line number. Because sometimes what happens when the program is made by the software or by the programmer, sometimes there errors occurs. So if the program is of 1000 lines, and when you come out after the running of the program, you will not find the line where the error has occurred. And if there is number behind that line, and from that number, for example, last I have shown 56, so you will straightforward go to the line 56 and you will change or you will modify that code according to your convenience so that error may not happen. So first digits are numerical values and their main aim is to identify, to give a line number to one particular line. Then comes your G codes and M codes. As I have said, G codes are generally used for geometric. It's are related to the geometric system, right? Whether movement or whether dimensions. And M codes, miscellaneous codes. Then you have X and Y and Z. Generally, X, Y, Z are used for coordinate system to show where we have to read. In X direction, what should be the value? In Y direction and in Z direction, right? Z direction is the movement of extruder in up and down motion, and X and Y is related to your bed, right? Along with this X, Y, Z, some other words are also used, that is I, J, and K. These are used when we have to work something in, you can say, in terms of when we have to make a circular motion, we have to give the radius of the circular. So we can use either word R, or we can use I and K. That is distance from the previous point to the center of that arc. Then word F is used. This is similar to your CNC machines, that is feed rate. Generally, it is given by mm per second feed rate. That is, if some value is written, for example, F300, that means you have 300 mm per second of feed rate. Now here, feed, when we talk of 3D printers, there are two kinds of feed rate. We should be clear which one is this. This is the motion of the extruder, how fast it is moving, and other is material coming out of the extruder, right? That command is given with the help of E. So generally, feed rate in conventional CNC machines is one, that is motion of tool or motion of your workpiece, depending upon the type of machine. But here we have two things. One is motion of your extruder, and other is your flow of material from the extruder. For both, we have two different codes. For motion of extruder, we have F, and for flow, we have E, right? Generally, for E, it is very important when the automatically the program is generated, the value of extrusion E continuously increases, right? Why it increases? And its value should never be zero if 3D printing is going on. If its value is zero, that means extruder is not coming, or your material is not coming out from the extruder. So there will be no 3D printing. And if your value is constant, like feed rate is constant, that means in the starting, some value we have given, that amount will come out, and that flow will stop. So there should be increase in extrusion value. It will automatically generate. Again, we have different two codes, G92, for this to set out how much extrusion should be come out, extrusion should be come out, again in mm per second, or per your inches per second. That dimension, that flow value, again unit has to be given, that are given by code G92. So it's very important that when we are using G0 command, because G0 command is used for motion while work. So there should be value of extruder, it should not be zero, and for each line it should continuously increase, it should not be constant. Then is your T. Generally 3D print extruder, right? So we generally use either T0 or T1. But sometimes we have more than one extruders, the system, our machine is big, then we can use this T0, T1, T2, T3, and in between if some extruder is being changed inside the your software, or inside that software, we change the tool by putting the word T1 or T2 or T3, whichever tool we want to use. Generally, sometimes the opening of the extruder is constant, right? Sometimes we want more material, so it's not always that we have to pressurize the flow. It can cause some defects. So we can use extruder with a bigger diameter, right? Then there are some other codes like M codes and S code. M codes are miscellaneous codes. We will discuss about some particular codes used in our 3D printing. Then S code stands for the speed. In case of conventional machines, S is for the speed of your. In case of lathe, it is speed of your chuck, motor speed. But here, this is a common word. It can be used for number of different motors. Just you have to specify and then use word. When S is used, that means some temperature is there, right? here this is the difference between the printer and convention. Conventional S is used for speed. Here when we write word S, that means some temperature will be there, right? So G codes generally created by different softwares, or you can create your own program in the different softwares available, which I have shown in previous slides. These are some commonly used codes. We will discuss about some of them, like G0, rapid motion, G1, G2, G3, G4, G28, G31, G90, G91, G92, G93. Like G0 and G1, these are the movement. When there is a G0, that is a rapid movement. That means at that particular motion, there will be no 3D printing, or there will be extrusion. There will be no material coming out from the extruder, or you can say that movement is very fast. At the maximum speed, the extruder can move in any direction. Then G1 is the linear motion, and when the command G1 is given, that means now some material will flow from the extruder, depending upon what value of E and F we have given. So this is the example. For example, if I write G0X12 and then G0F1500, so it will move to the point 12 mm in X direction with the feed rate of 1500 mm per minute. And like G1, X0, X some value, Y some value, and then E. Now here previously we have given G0, there was no value of E, but now we have to give the value of E. That is how much material will come out from the extrusion when this command is being followed. Similarly, if G1, F15 and extrusion is here, then we have a motion of extruder that is 1500 mm per minute, and the flow will come out with the value of 22.4 mm. And even in one go, it's not like that the motion of extruder will be same, that is feed rate is constant. It can vary. So suppose we have G1 is equal to F50, that means when we are starting to reach point X50 and Y25, initially the value of feed was 1500, and when it reached that point, the acceleration has gone to 3000. So there can be variation of extruder also. That is not, it should be constant. It can be constant or it cannot be constant depending upon our requirements. Then G2 and G3, these are used for motion in a clockwise direction or anti-clockwise direction. G01 is for linear motion. It can be horizontal, vertical, or inclined also, but it should be in a straight line. But when there is some curve, then you have to use word G2 or G3, where G2 stands for a clockwise rotation and G3 is anti-clockwise or counterclockwise. Now, as I have said, we can use the word I and J here. Now, I and J is 5 and 10. That means from where we have started. Suppose if this is to be followed, so this value is this point. So value of I and 10, this will be, there will be some center of this arc somewhere here. So this I and J will be the distance from this point to this point. I stands for the distance in X direction and J stands for the distance in Y direction. So as we can say here, I is 5 and J is 10. That means it will start somewhere from here, right? So similarly, in anti-clockwise, in this case, our extruder is moving in this direction. In anti-clockwise, if I am again starting from here, but now my motion is in anti-clockwise, then it will move something like this. Then your center will come somewhere here. Right? So you can see there is change in shape when you are using G0 code clockwise, and when you are using G03 for anti-clockwise, this direction. Okay. Then is dwell. I think you might be knowing about this. That is G. That means extruder while moving will pause for some time for there. For in case of 3D printing, we have two codes for it for the pause. That is P and S. P stands for the pause is for milliseconds, and if we write S, it will give the value in seconds. How much seconds or how much milliseconds, right? So as it is example is here, G4 P200. G4 means dwell and P200 means we have to pause there for 200 milliseconds. And during this, there will be no flow of material from the extruder. Then there are codes G90 and G91. Whether our extruder is moving in terms of your incremental method or absolute. In case of absolute, our 00 is 1 in one particular point, and all the dimensions are related to that point. Reference is only 1 point. But in case of incremental or relative position system, the previous point becomes the reference for next point. Right? So accordingly, we have to give the code. Sometimes what happens, we have to create the object, or we have to start the motion of extruder from the previous point, or we create some layer system in our model, or we want some that previous all the values should be forgotten. Then we can choose this G91 code. Sometimes all the codes are in one type, that is absolute position or incremental position, and in some cases we first start with our absolute system, and then in between we change to the incremental, and then again we go to the absolute. So there these codes can be used. Then G92 to set current position as a 00. And that means if suppose this is a figure